math number 150 at Franklin University, test number 3, review with and by JoAnne Myers, 25 problems. Number 1, solving a rational equation. Again, rational means there are fractions. Find your equal sign. Remember that you can creatively rewrite the value of 1 any way that you want. I'm adding on the right side, so I'd like a common denominator. So I choose to rewrite that 1. Then I rewrite the rest of the problem. Simplify the right side. 3t plus t becomes 4t. So my numerator is 4t minus 4. When you add fractions, the denominators stay the same. Now, I have a fraction on the left. I have a fraction on the right. Quick review. If you have two fractions that are equal to each other, if you multiply both sides by the same thing and reduce, you can end up with AD equals BC. So if you are given this situation, then before you learn algebra, we teach you something called cross multiplication that shows that these two situations are really, these two equations are the same. What you have actually done is multiply both sides by your denominators, which gives you your AD on the left and your BC on the right. So because those who have gone before us have proven that, and I have just proven to you that those two equations are the same, given this situation right here, where a fraction equals another fraction, I know that t plus 2, what's on the left side, or my a, multiplied by the 3t, will have the same value as this t times the 4t minus 4. Yes, you could have factored that 4t minus 4 if that would be an easier way for you to work with that problem, fine. But we do not have to factor at this point. Now I multiply the left side. If you prefer to have it written as 3t times t plus 2, remember your commutative and associative properties let you multiply in any order. So if you're more comfortable multiplying with the monomial 3t first, that's fine. The right side, t times the quantity 4t minus 4, you will distribute that t that's on the left. Left side, 3t times t is 3t squared. 3t times 2 is 6t. So I now know that the left side and the right side are still equal. I am just rearranging or simplifying the right and left equations. Now is where I'm going to do something different to both sides. I have t squared and t squared. I like my coefficient to be positive, so I'm going to choose to subtract the smaller version. I'm now left with 6t. Is the same thing as 1t squared. Apologies, get those up there. And then I have a minus 4t. Because I have a t in every term, right here at this point, my goal has become to set the equation equal to 0. Q-U-A-T-I-O-N. So right here at this point, that's become my goal. So now I'm going to subtract 6t from both sides. Notice I'm keeping my equal signs lined up. So I now have 0 is the same thing as t squared minus 10t. Now my goal is to factor. or use the quadratic formula. Quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And then remember both terms, the minus b and the radical, are all divided by the 2a. So I'm actually going to factor this one. I can factor out a t, and I'm left with t times t minus 10. So now I set each factor equal to 0 and solve. So I have t equals 0 and t equal positive 10 are my two solutions to this quadratic equation. The solutions to the original equation are when t is 0 or when t is 10. Here's an image of the entire problem from start to finish. This is what we were given to start. And the two values that make the original equation true are when t is 0 or when t equals 10. So the solution set for number 1 is the set of numbers that include the number 0 and the number 10. If you wanted to write it in set notation, then you would write the set of all numbers t such that t equals 0 or 10. Another way to write it is just the set that contains 0 and 10. If you give me 0 and 10 on the test, that will be fine. Number 2, very similar, solve this equation. I'm going to solve this one differently. Write down the equation on your page. And then notice, after you factor, I'm looking for a common denominator. In my denominators here, I have a w minus 1, I have a 3 times w minus 1, and I have a 3. So the smallest common denominator that I can have is a 3 times w minus 1. Because this is an equation, the left side and the right side are equal. So my two favorite rules in math, I can multiply by a value of 1. Or if I have an equation, I can do whatever I want to both sides of the equation. In this case, I first choose to multiply the left side of the equation by the value of 1 written as 3 over 3. And the right side, I multiply only the second term. So I now have negative 12. Negative times positive is negative. And notice all of my terms are the same. The right side, because I'm adding or subtracting, and these denominators are the same, when I add or subtract, I'm left with the same denominator. So 6 minus, and I'm going to distribute at the same time, 2 times w. Negative 2 times negative 1 would give me positive 2. So I have a negative 2w plus 8 in my numerator on the right. I have a negative 12 in my numerator on the left. I can cross multiply as before, but instead, because this is an equation and we're allowed to do whatever we want to both sides of an equation, I'm going to choose to multiply both sides by 3 times the quantity w minus 1. Notice I'm not multiplying by 1, I'm actually multiplying by a value. The reason I'm choosing to multiply both sides by this value is the left side, when I multiply out, it will reduce to be a negative 12 on the left. On the right side, because this mystery is the same value as this mystery, they will reduce. And I'm left with just a negative 2w plus 8 on the right. My goal here is still to isolate the w. My goal is to find what number does w have to equal. Okay, I want w by itself. What's blocking my goal is that plus 8. So I choose to do the same thing to both sides of the equation. I find out that the equation above has the same value as negative 20 equal negative 2w. The opposite of multiplying by a negative 2 is dividing by a negative 2. Negative divided by negative is positive. My goal is to isolate the w, and so I'm rearranging the equation any way I want until I isolate that w. Here's what all of number 2 will look like from start to finish. This is the original equation they gave us. My goal is to find some number for w that makes the equation true. So I'm going to do whatever I want to both sides of the equation. I'm going to multiply by a value of 1 whenever it makes my equation easier to manage. And then I will just keep rearranging until I've isolated that w. That was the original question. Number 3. Determine if the relation defines a function. A function has to have a one-to-one correspondence. So I'm going to first look at all of my x values, y values. Personally, I like to graph these. So negative 3 if graphing is going to take too long, you can actually look at each of these. I think this look at my x values. Because each of my x values will be at their own unique place. 1.4, okay, negative 3.1, 1/3, 1.4, and negative 4. These are each unique x values on my x number line. My vertical line test will be satisfied because negative 3.1, 1.4 will be somewhere around here. That's my point A. Point B, 1/3, 6, 1/3 up 1, 2, 3, 4, 5, 6. 1/3, 6 would be about right there. If that's my point B, there's my point A. 1.4, negative 3. About here. And then negative 4, negative 3. If these are my points A, B, C, and D, they will in fact pass the vertical line test. So yes, it is a function. All right, so this problem right here, number 3, it is a function. This relationship between the x and y coordinates, it does actually represent a function because it passes the vertical line test. In other words, each of the x values maps to one unique y value. Number 4, sketch a graph by completing the table and plotting the points. There's a space to sketch your graph, completing the table, and plotting the points. This test, do you understand how to use a function? They're telling us that the function named h takes only one variable. We're going to call that variable x. What is it going to do to x? It tells us on the right side of the equal sign that it's going to take whatever number we give it and cube it. Now this here is a typo in Alex because this should say f of x equals x cubed. So then if my x is given, if x is -2, then h of -2 is written like this, h of -2, well, h takes its mystery and then cubes it, so h of -2 is -2 cubed, which is -2 times -2 times -2, so that means the point -2, -8 is a solution. H of -1 is the same thing as -1 cubed, -1 times -1 times -1. So this tells us that the point -1, -1 is on our graph. H of 0 means we have 0 times 0 times 0. So if my x is 0, my y output is 0. The x input, the y is the output. H of 1 is 1 cubed, 1 times 1 times 1. So my input is 1, my output is 1. H of +2. Notice when the numbers are positive, I don't have to have the parentheses. It's not wrong. 2 cubed is 2 times 2 times 2, which is 8. So when my input is 2, my output is 8. So then we graph these coordinate points. I have the point -2, -8. I have the point -1, +1. The point 0, 0, 1, 1, 2, 8. If I were to pick another number, h of 3, put the number 3 into my function named h. The function again takes what it's given and cubes it. 3 times 3 is 9, times 3 is 27. So that means if my input is 3, my output will be a 27. So I did one extra point here just to emphasize the fact that this is not a linear equation. This is a cubic equation. So if I go over 3, then I'm going all the way up to 27. So my graph is a curve that goes like this and then curves and comes down. We put arrows at the end to let everybody reading know that it continues on forever. The end behavior is as my x gets forever larger, my y output will get forever larger. As my x input gets forever smaller, my y output will get forever smaller. This is the parent function for a cubic equation. Everything that is an equation or a function of third degree will have this general overall shape. You do need to know the parent function for a cubic. Looks like this. We can write it as y equals x of x cubed, or in this case, h of x equals x cubed. Again, it's not h times x, it's the function named h. It's going to take one variable that we call x. And then here's our graph. Here's what our chart would look like. There we go. Number 5, identify the domain of the function. Identify the y-intercept. Write your answer as an ordered pair. What we are doing here in number 5 is recognizing key points. So then we can graph, or at least what we expect you to do here in Math 150 is recognize which graph does it have to be. So we ask you some basic questions. First, identify the domain of the function. The domain, there are 2 factors. We are never allowed to have a 0 in the denominator, and we are never allowed to have a negative under a square root. We have no square root, so we don't have to worry about that in this case. But whenever you're asked about the domain of a function, the 2 things you always need to remember through calculus and beyond: no 0 in the denominator, and no negative number under a square root. You can have a negative under a cube root, but not under a square root. So in this case, I'm going to set my equation x plus 2. I'm going to look at only the denominator and set that equal to 0 and solve. All right, whenever you get a question about the domain, remember that the domain is the set of all numbers that are allowed into your function. Which values are you allowed to use? We have k of x equals 1 over x plus 2. So given the function k of x is the same thing, 1 over x plus 2, we are allowed to put every number into our function called k such that it will spit out a real number. Now, we are not allowed to have a 0 in the denominator, so this can never be 0. So what we do is we solve for when it is equal to 0. This one's pretty easy to see. You're going to subtract 2 from both sides of the equation. You'll recognize you have a problem whenever your x is negative 2. So x is not allowed to be negative 2. So identify the domain of the function. So my domain is everything except negative 2. It's everything from negative infinity all the way to the left, coming up to negative 2, but not landing on it, joined with, again, everything close to negative 2 on the right side, going on to positive infinity. Another way to state my domain is to state that it's all real numbers, so long as x is never 2. All real numbers, except x is not allowed to be a negative 2. 2 different ways to state what the domain is. I'm using interval notation in the top. Identify the y-intercept. The y-intercept is where your graph crosses the y-axis. The y-intercept always has a coordinate where x equals 0. So you're going to solve, instead of k of x equals 1 over x plus 2, solve that for x equals 0. Remember, k of x is the same thing as y. So here we go. 0 plus 2, no problem. So my y would be 1/2. So when x is 0 and y is 1/2, that is my y-intercept. So now I'm to match the graph. They're not asking me to graph, they're asking me to match the graph. So given these options, I know that on the graph, when x equals -2, it is not supposed to have any point. X equal -2 is not allowed in this function. But look, B, C, even D, all but one of these so far actually have a solution for the x input of -2. So just looking at this, I know all of these graphs are eliminated. Make this a little bigger for you. Again, I'm looking at my domain. All of these points are in these graphs. This is how I know there are only two possibilities left, just by knowing my domain. Okay, there will be a point up there. This has a point there. So the only possibilities right now are A and I. So just by knowing your domain and knowing that my x value is not going to exist when x is -2, it tells me all but two of these are eliminated. Now I also know the point x is 0 and y is 1/2 is my y-intercept. So which of these two graphs has the point 0, 1/2? Well, 0, 1/2 would be right there, and 0, 1/2 would be right there. So this information tells me that this point 0, 1/2 has to be on my graph, and the only one that has that is A. So this is the final answer. A is the graph. If given these options, the only one that can be the graph of this function, k of x equals 1 over x plus 2, the only graph it can be is A. All right. Again, the question is up here. Match the function with the graph. All right, number 6, solve the compound inequality and graph the solution. Write the answer in interval notation. Write your answer in exact simplified form, and then graph the solution. So compound inequality means we're going to have things that are unequal, and we will have two parts. Reminder, we flip the inequality when we are multiplying or dividing both sides of that equation by a negative number. So we flip the sign when we're multiplying or dividing both sides of the inequality by a negative. Okay, when you solve an inequality, you treat it like an equality. You do basically whatever you want to both sides of the equation to isolate your variable. You keep the inequality in your equation. So here we go, the first one. I'm going to subtract 11 from both sides. I'm adding or subtracting, so rewrite the inequality just as you see it, 43 minus 11. Now the opposite of multiplying by k is dividing. So I'm now dividing. As soon as I multiply or divide, I stop, I ask myself, did I divide by a positive or a negative number? I divided by a positive 4, so there's my answer. So I need to find all of the values for k that are less than 8 and whatever I get on this right side here. So I'm going to get rid of 18. 53 minus 18. I'm adding or subtracting. So I'll write down the inequality. I'll have 35, and I'll be left with 7k plus 0. 7k plus 0 is just 7k. The opposite of multiplying is dividing. So here again, I'm dividing, but I'm dividing by a positive 7. So my answer is k greater than 5. So I'm looking for k less than, but not equal to 8. So smaller than 8 and not equal to 8 means all of the numbers going that way towards negative infinity. And then k greater than, strictly greater than 5 means not 5, but everything close to 5, and all of these numbers bigger than 5, headed toward positive infinity. So the only part that satisfies both equations is the part in the middle. So it would be the numbers from 5, not including 5, up to not including 8. So in interval notation, I would have parentheses, because you use parentheses when you have less than or greater than, and you use the brackets when you have greater than or equal to, less than or equal to, or greater than or equal to. So these are your scenarios. Parentheses, if there is no equal to, brackets, when you have the equal portion with your inequality. This would be your answer. And my graph, what I would put into Alex then, is not this whole thing. I would need to erase those parts. And my graph would be just this part here, here, and the middle. That's my graph. That's my interval, and I'm done. Because this was an and. I had to satisfy both the green and the blue inequality. Number 7, solve the inequality graph, write interval notation. This compound inequality, here are my inequality symbols. I need to isolate the b, so the first thing I'm going to do is add or subtract. You could divide first if you wanted to. In this case, it would not be too terrible, but often if you divide first, you end up with fractions for the remainder of your problem. So all of this simplifies to be just 5b, 0 plus 25, minus 20, plus 25. I want b by itself. The opposite of multiplying is dividing. Again, I'm dividing. But what I wrote down was that red 5, so I have divided by a positive. So my inequalities will stay the same direction. If they want set builder notation, I would just say the set of all b. This would be set builder. They're not asking for it here, but here it is, just as a reminder. And then the graph, I need less than or equal to 5. I need greater than 1. So all of my solutions will be here, but it will include 5 and it will not include 1. So this is what my graph will look like. My interval notation will be everything bigger than 1, but not equal to 1, and everything less than 5, and it could be equal to 5. So I'll put the bracket to show the endpoint is included for 5, and parenthesis to show the endpoint of 1 is not included. That would be my answer. This would be my set builder, and this is clearly my graph for that original equation, if you want a screenshot. Next problem. Number 8. Solve the compound inequality. In this case, it's an or. I need to find all of the W's that will make this equation or this equation true. Well, the one on the left is simplified, as simple as it can go. On the right, I want to isolate the W. So I will do whatever I want to both sides. When I add or subtract, I simply copy the inequality. 18 minus 3. All of this becomes 5W. Instead of multiplying, I'm going to divide. So I divide both sides by 5. And the right side becomes W. Again, I'm dividing, but it's dividing by a positive number. So I have W is strictly greater than or equal to 3. Or W can be strictly less than 0 to graph it. Smaller than 0, the parenthesis needs to go that way. And my arrow, so all of the numbers smaller than 0, greater than or equal to 3 means at 3 it could be equal to 3, or everything bigger. So that's my graph. Again, to the left is negative infinity, to the right is positive infinity. So when I write my interval notation, it's negative infinity, and we always have a parenthesis by positive or negative infinity because it's not an actual number. And then a bracket here for my 3 to show that 3 would make the equation true. And then positive infinity, meaning everything bigger than. So here's my set builder. Here is my graph. And if I needed, I'm sorry, that's interval notation. Set builder would be the set of all W such that, and then you just write the equation. W is less than 0. Or W is greater than or equal to 3. And that would be your set builder. You will be asked about interval, set builder, and graphing on the test. Solving an absolute value. Again, solve means find all the values for your variable that make the equation true. So I'm going to start by trying to isolate the absolute value. Okay, so I'm going to add 8 to both sides. If you get 0 as an answer, that's okay. Please make sure your equal signs stay lined up. I now have 4 times the absolute value of something. So the opposite of multiplying is dividing. So I'm going to divide both sides by 4. 0 money divided by 4 people is 0. And so I will be left with the absolute value of 9y plus 6 equals 0. So now here where I break it into 2 equations, I would have 9y plus 6 equals positive 0, and 9y plus 6 equals negative 0, but there's no such thing as positive or negative 0. So I really don't have to work with this because it's the same equation as 9y plus 6 equals 0. And I'm already solving that over here. 9y is the same thing as negative 6. Divide both sides by 9. Always reduce your fractions. So I would have negative 2/3. And if I solve this, I would have the same thing. Y is negative 2/3. So it happens to be the same answer. Solving this inequality, number 10. Same steps. Same rules for when it's an inequality. I would isolate my absolute value. This problem's already there. So now when I write my two equations, I will copy one exactly. 6 is less than 2k minus 4. The other equation is going to be a negative 6 is greater than or equal to my 2k minus 4. Notice that what is in the parentheses remains the same. The inequality stays the same when the number stays the same. And the inequality changes direction when the value of what's on the opposite side of your absolute value is made negative or changes sign. All right, now I have these two equations. I'm going to add 4 to both sides. I'm adding or subtracting the inequality. So I have 10 is greater than or equal to 2k. The opposite of multiplying is dividing. I'm dividing by a positive 2, so I just copy down the inequality. So I have this situation. And then here, to get rid of that minus 4, I would add 4. Minus 6 plus 4 is a negative 2. Again, I'm adding or subtracting, so I do not change the direction of my inequality. Because this is multiplication, I will divide by that 2. I'm dividing by a positive 2, so negative 1 is greater than or equal to my k. I really prefer to graph these. So I've got something going on at negative 1, something going on at 5. K is less than or equal to negative 1. Less than or equal to negative 1, smaller than negative 1 goes to the left. K is bigger than, or 5 is smaller than or equal to, or K is bigger than 5. So that would be all of these numbers. So then my interval notation would be negative infinity to negative 1 with a bracket, parenthesis by the negative infinity, bracket by the negative 1, because there's an equal sign in my inequality. Or a number that's equal to 5, and then all of the numbers greater than 5. So there's my graph. There's my interval notation. If I needed set builder, it would be the set of all k such that, and then I would write it as k less than or equal to negative 1, or k greater than or equal to 5. Put your other squiggle, and then that would be your set builder. Question. Go back down here. Again, you're going to isolate your absolute value and then rewrite into two equations. You flip the inequality. Now notice here when it was an equality, we didn't really need to flip anything, but we still had two equations, one where it was positive and one where it was negative. We just had a unique case with our equality because our absolute value equals 0. And since there is no positive and negative 0 for number 9, we just had one problem to solve. In number 10, we broke it into 2 and we had 2 to solve.